welcome back and welcome to my garage again. Today we're going to start with chapter 15 from our book, Introduction to Logic. All right, chapter 15 is about category logic. Category logic. This comes originally from Aristotle, okay? So originally from Aristotle, the ancient Greek, or you could say Macedonian philosopher. It is still used, even though he creates it around 300 BCE. It's still used. It's still useful. And it was the primary logical system for, all the way up till about 1900, even later. Okay? Now, let me contrast it with the logical system we've already looked at, and that is propositional logic. Remember, in propositional logic, our statements took this kind of form. We had things like circle, arrow, square. All right? We had something like this. If something's a cat, then it's a mammal. All right? But look at that. What goes in for circle here is something is a cat. So the arrow stands for if, then. So if something is a cat, something is a cat fills in for circle right here. What fills in for square here is it's a mammal, right? Something is a cat. If something is a cat, then it's a mammal. Notice that what goes in circle right here is itself a proposition or statement. It's either true or false here. It's a sentence here. Something is a cat. Here we have the statement, claim, it's a mammal. So, a logical system that focuses on statements, that uses statements of this form, circle, arrow, square, circle and square, circle or square, circle, double arrow, square, is going to be called propositional logic because the elements, the components of those statements are made up of propositions. Category logic, you can guess, will feature a system that focuses on statements that are made up of categories. Okay? So statements that are composed of categories. There are other words for categories as well. We'll get to that. But let me just give you a little example. If we say something like, all cats are mammals. Now this is of the form, all circles are squares. So that's the form. Now notice what goes into circle right here and what goes into square here are not propositions at all. They are not statements that go into here. They are categories, or they point to categories here. Cats, that refers to a set of things. Sometimes we might call, so this would be a category. These are categories here. Sometimes it's called, they're called sets, classes, and we'll also often use this term as well, or this word, terms. Okay, it refers to a set of things, a set of cats. Okay, members of a class. Take a cat, it is a member of a certain class of things. And see how that's opposed to the circles and squares in propositional logic. The circles and squares here in category logic refer to categories. Circles and squares in propositional logic refer to propositions. Now, if category logic is so old, it's old, ancient, you might say, and propositional logic is so new, why are we even learning category logic? I think there's two main reasons. One is that category logic it actually has some advantages. It can do some things that propositional logic can't, or can't do very well. Can't do very well. Also, here's a second reason. In some ways, it's just easier than propositional logic. Just easier. Oh, I might as well add a third reason, I guess. It helps bridge us to the final system we're going to look at in this class. Helps bridge us to what's called predicate logic. Because predicate logic combines both propositional with category logic. Predicate logic looks like that. So, yeah, I guess these are the two main reasons here. I don't know. No, the third one's pretty important too. So, yeah, 3 reasons to engage in category logic. Now, let's get to this. Yeah, let's defend some of these right here. The first 2 at least. Can do some things that propositional logic can't do. All right, take the following sentence. Some humans are, let's say vegans. Vegans, strict vegetarians, okay? Some humans are vegans. In propositional logic, how would you symbolize that? How would you translate that into our system of propositional or statement logic? It would be something like H. You'd say, oh, that's a simple statement, not a compound statement, and we would just maybe use this letter H here to stand for some humans are vegans. Cool. So that works, I guess, in propositional logic. That's how you translate or symbolize this English language statement. Now, category logic, on the other hand, would symbolize it this way. Some H, and H would stand for humans, category, are V, and V would stand for vegans. Okay? This is category logic here. This would be in propositional logic. And look at the forms too. So here the form would just be circle, and here the form would be some, you could say circles are squares. Although, keep in mind, that's not the same circle. It's a little different, right? The circle here is a proposition, the circle here is a category. But now compare these 2 symbolizations. Which one is more precise? Other things being equal, which one is more precise? This one is. This relates 2 elements together right here. 2 components together. Gives a relationship between those 2. Here, there's 1 component. It is, and we call it a simple statement. Here, yeah, in some sense, I guess you would say it's simple. It's making one claim about the universe, but it's relating 2 elements together. In some ways, it's more sophisticated. In some ways, it's more accurate, more precise. So there you go. Some things that propositional logic can't do or can't do very well. This is not as good as this. Does that make sense? Okay. Easier than propositional logic. Now, this is going to ease us into Aristotelian logic. Aristotle divides all categorical statements. So these would be statements used in his logical system that relate categories together. He divides all categorical statements into just 4 kinds. Into just 4 kinds. And so let's talk about those 4 kinds of statements. The first, and let's use circles and squares. All circles are squares. And I'm not going to put an S in there, I'm just going to save some ink. All circles are squares. Okay? We'll talk about what these mean too. No circles are squares. Okay? Some circles are squares. Yeah, we saw that right there. Okay? Some circles are squares. And then finally, some circles are not squares. Let's talk about what each of these statements means. Yeah, look, there's just 4. So in that sense, it's easier than propositional logic. Propositional logic, there are 5 truth functional operators, so in some sense, that's pretty simple. But statements can come in all sorts of forms. Unbelievable variety. Here, much simpler in that sense. It also makes it so the system is more limited than propositional logic, sure, but in some ways it's easier. Okay, it's not as powerful, but it's useful in a limited sense. Okay, all circles are squares. What this means is that, well, let me talk about the form of these here. What we have here, we have a statement that relates a subject here and a predicate. So let's call right here the circles, these circles here represent the subject term in each of these statements. And the squares represent the predicate term. You're like, wait, this is English class again. Yeah, English sentences relate a subject and a predicate. They have a subject and a predicate. So here we have the subject, circle, okay? And you're saying every member of that subject term, let's say gorillas, every member of the set of gorillas, okay, is included in the set of, let's say, vegetarians. All gorillas are vegetarians. So the subject term is included in the predicate term. Here, no circles or squares. You're saying every member of the subject term is excluded. So this first statement here is inclusive. This is exclusive, you could say. Some circles are squares. That means at least one member. Some means at least one. At least one member of circle is included in the square set. So for example, at least one human is vegan. The final statement here, some circles are not squares. At least one human, let's say, fill in circle, put in humans there, and then plug in vegans here. At least one human is not a vegan. At least one human is excluded from the predicate term. Does that make sense? Let's say a few more words about these 4 kinds of statements. Okay, let's do it over here, I guess. All right, so let's give an example here. So we say something like all gorillas are vegans. Let's say that. Okay. And as we said before, the subject here, every member of the subject term is included in the predicate term. All right. Aristotle calls this, and you could call it, I mean, this makes sense. It is a universal affirmative statement. Why? Universal means that it talks about every member of the subject term. Universal. Affirmative means it's inclusionary, right? Every member of this class is included in this class. So, universal affirmative. It came to be called an A statement, capital A. So sometimes I'll use that, I'll say, give me an A statement, all right? Or what kind of statement is that? You might say, it's an A statement. All right. Our second statement, as we talked about before, no, let's say, let's do coyotes, right? I don't think any coyotes are vegans. It would be an odd coyote. All right, no coyotes are vegans. Are you talking about every coyote when you say no coyotes are vegans? Yeah, you are. So that is a universal statement. But it's excluding coyotes, the set of coyotes, from the set of vegans, so to speak. So we would call this universal negative. And this is labeled E, an E statement. Right? Actually, A and E actually comes from the Latin. So affirmo, the A right there. And the Latin for I deny, nego. The E, an E statement, if you care. Okay. Third one, some, let's say, what did we do before? Oh yeah, humans. Humans are vegans. All right. You're not talking about all humans. You're just saying at least one human. So this kind of statement is called a particular statement. Is it affirmative or is it negative? Well, it's including at least one member of the set of humans, all right, into the set of vegans. So it would be called affirmative. Affirmative. And it is an I statement, which refers right there, I to affirmo. Again, if you care. Why did I wrote it affirmo? Affirmative, to use the English. All right, particular affirmative. And then finally, see if I have room right here. We have the fourth kind of statement. Some humans, here's an example, are not vegans. So this is, again, not about all humans. At least you're not committing to making a claim about all humans. You're just saying at least one human. So it's a particular statement. And it's negative. By the way, nego, the O. So it's called an O statement. All right? A, E, I, and O. Let me quickly diagram what these statements are doing. Take an A statement. What an A statement does, by saying all gorillas are vegans, it's really saying take the set of vegans. Just imagine that set, right? So this circle would represent, right, all the vegans in the universe. Right there. When you say that all gorillas are vegans, you're saying this, in a sense, that one set or circle is contained within, wholly contained within another circle, right there. So an A statement can be represented using this diagram. An E statement, you could say, is doing this. Take the whole set of vegans and then the set of gorillas, and there's no overlap. That's what you're doing right there. An I statement, well, let's see. I guess you could do something like this, right? You could overlap the two. Take the set of gorillas, take the set of vegans, and you know something? There's at least one thing in here. So, you could represent that one thing with, say, I don't know, an X. There's at least one gorilla we represent by this X right here. You're not saying which gorilla it is. You're not saying, oh, it's Joe the gorilla. You're just saying there's at least one gorilla that is also a member of the set of vegans. So you can represent it that way. I, well, you could take here the set of gorillas, the set of vegans. You can maybe overlap them and say, hey, there's at least one gorilla. Oh, no. Oh, we're talking about humans right here. Okay, get back here. Humans. Humans, just to be consistent. Humans. Okay? So at least one human that's vegan. Here, humans. Now you can put the X out here. There's at least one human that's not a member of the set of vegans. By the way, these right here are actually Venn diagrams. In this class, and on these videos, I'm not going to teach you Venn diagrams. But it just so happens, with regard to at least I and O statements, Venn diagrams are pretty intuitive. They're pretty natural. Okay? These two right here, these two diagrams for A and E, they are not Venn diagrams. They're just an intuitive, kind of common sense way of representing those two kinds of statements. These are all called, these right here, A, E, I, and O, these are called standard form categorical statements. Memorize these forms. The next video that I'm going to create is to take English language statements that are not in standard form and then translate them into standard form. And you can see that we'll be able to actually take a lot of English sentences and do that. Ones that don't initially look like they'd be categorical statements actually are. We'll put them in that form. Some of them will be a little bit tricky, so wait for that video. All right, see you next time.